So in the previous video, we've looked at ways that we can increase the rate of a reaction. So that means make the reaction go more quickly, make it go quicker, make it go faster. And the first factor that we looked at in that video was increasing temperature. And we learned that at higher temperatures, reactions will go quicker. The rate will increase if we increase the temperature. Now I said that there were four main ways, four main factors, that if we change them, we can increase the rate of a reaction. So the second one in that list is concentration. So concentration, basically, is just the amount of stuff in a given volume. So what does that mean? Well, it's kind of like density. So if I had a certain volume, let's pretend it's a volume of liquid, and let's pretend that that volume of liquid is orange juice, okay? So I've made up 2 glasses of diluting orange. You can see from the left-hand side that this one doesn't look very orange at all, and the one on the right looks much more orange, all right? So what have I done? Well, you can see in both cases that both have the same volume of liquid, right? The glasses are the same size, and I filled them up to the same height, so they have the same amount of liquid in them, right? However, the one on the left, I've used much less orange juice to mix with my water, and on the one on the right, I've used much more orange juice to mix with a smaller volume of water. So, for the same volume, the glass on the right-hand side has significantly more orange juice particles in the same space than the one on the left, because the one on the left has more water particles than the one on the right. So, very importantly, we don't ever use strength to describe this, right? This glass of orange juice on the right is not stronger than the one on the left. That's not really chemically correct. What we want to say is that the glass on the right-hand side has a higher concentration than the one on the left. That is to say, it's got a higher concentration of orange juice particles than the one on the left. So it's more concentrated. So it's going to taste more like orange juice, right? And that's what we mean by concentration. So just the amount of particles in a given space. So it doesn't change the total volume that we have, right? I'm not using a higher volume of orange juice. I'm just cramming more orange juice particles into the same space. Okay? So having more reactant particles in a given volume, of course, will mean that they're going to bump into each other much more often because there's just so much more of them within the one space. Okay? So if they're going to do that, if they're going to collide more, thinking back to the previous video, that's exactly what makes a reaction successful, the fact that there are more collisions. And if there's more chances of colliding, the reaction rate will increase. So, by increasing concentration, we can increase the rate of a chemical reaction.